Hey everyone, it's Mrs. Brimlow, and today I'd like to teach you how to find the area of what we call composite or compound figures. If you have the packet, I believe this is page, this is page 21. I apologize, I had to double check my count. So this is page 21 in your packet, looks like this, or you can get a copy linked to Canvas to today's playlist. Okay. All right, so what is a composite figure? Let's start there. A composite figure is also known as composite shape or compound shape, and it's basically a shape that is made or constructed from two or more geometric figures. So today we're going to talk about how you find the area of something like that. I've written out the directions step by step here, but I want to go ahead and dive in with this first example. So you're going to notice I have the same shape twice, and we're going to talk about why in a minute. So if you turn your paper, it kind of looks like the letter L. Okay, this is an example of a composite, compound, irregular figure. I don't have a formula to find the area of this exact shape. However, I know that composite figures are made up of at least two or more figures or shapes. So what I could do to find the area of this is I can start by breaking it apart to shapes that I know. Now, the thing that I love about working with composite figures is that there's so many ways to break down a composite figure. And depending on how you see it, it doesn't make it wrong. You just have to make sure you have the right measurements to find the areas of your figures that you break it down to. So if I was to look at this, this is how I would probably want to break it apart right here. Okay. So I have this rectangle and I have this rectangle. So I know how to find the area of a rectangle. So I just need to do it for each of them. So once I've broken it down, that's step one. Step two is to determine all necessary side lengths. For example, this whole side right here is 6 feet. But for this rectangle, I only need this amount of it. So I have to figure out what that side length is to properly find the area of this rectangle. I'm going to call this 1, and I'm going to call this 2. So first, I'm going to find the area of this first rectangle, and that's going to be multiplying length times width. So I need to check, do I have the measurements from here to here? It's 3 feet. And then I have from top to bottom, which is 5. So 3 times 5, which is 15 feet squared. Step 2, find the area of the second rectangle, which is still going to be length times width. So once again, I have one measurement, but I don't have this one. However, I can figure it out using other parts of my shape or figure. So this whole side right here is 6 feet, okay? And I just need to find what this side length is, so that way I can use it to find area. Well, if I look at the opposite side, I know that this side is 3 feet, which is part of this 6 feet. So if this is 6 feet in total across, this is 3 feet from here to here, then this plus this has to be 6 feet total. Or I can take this and subtract what I have, which is 3. So 6 minus 3, meaning this is also 3 feet. Okay. So that means I'm going to be doing 2 times 3, which is 6 feet squared. So I have two areas, one for each of the rectangles. However, I want one area for the whole figure. So 15 plus 6 equals 21 feet squared. So that is the area for this figure. Okay. Now, that's how I saw the figure, but you might see it differently, and that's okay too. Another way a lot of people see this figure looks like this. I'm going to call this 1, and I'm going to call this 2. Now, we already know the answer is 21 feet squared, but that's pretty helpful because as long as I set up my work correctly, I should still be getting the same answer. So number 1, I'm going to check, do I have my measurements? This and this. I do. So 6 times 2 is 12 feet squared. So number 2. All right, so this times this. Okay, so once again, this whole side is 5 feet. However, I only need this much of that side. By properties of rectangles, if this is 5 feet, then from top to bottom is 5 feet here. So 5 feet here, only 2 feet here. 5 minus 2 is 3. So that part is 3 feet from this line we drew in to the bottom. So now I can find the area of that rectangle, length times width. Actually, this is technically a square since it's the same side lengths. So that's 9 feet squared. So when I add it all together for the total of this figure, I should have 12 plus 9, which is 21 feet squared. You can see these are the exact same. We just broke it apart 2 different ways to find the same answer. So once again, that's the beauty of working with these figures. You could even break this down more. You could make this into 3 figures or shapes. That might not be the best approach to take, but if that's how you see it, that's how you see it. So you want to make sure that you are breaking it down to shapes that you know and can find the area of, and you want to try and be efficient. So it wouldn't make sense to break this down to more than the 2 shapes we have because that's all we really needed, okay? So I'd like you to pause and try and find the area of this figure, breaking it apart however you see it best. And then I'd like you to come back so you can see how I broke it down and see if you got the same area. Okay. So when I look at this figure, there are 2 different ways I could break it apart. The way I saw to break it apart immediately was like this. Okay. And so what I see here is a trapezoid and I see a rectangle. Now, some people might have broken it down even further. So you had a triangle and 2 rectangles. Maybe you split it across this way horizontally. So many different ways for this shape. It's just whatever you see. So I'm going to go ahead and go through the process of how I saw it and then see if you got the same answer. So area of figure 1 is a trapezoid. That's the shape. If I turn my paper, this is a trapezoid. So it just has a right angle in it. That's okay. And so if I was trying to find the area for this, it would be base 1 plus base 2 divided by 2 times the height. Okay. So your bases are the parallel lines along the top and the bottom of your figure. So this is 4, and this would be 9. It's parallel to this 9 of this rectangle. So 4 and 9 are my bases. I'd add that divided by 2 times the height. Okay, so height is always from top to bottom. If you had 2 sides that were at an angle, it would still be from top to bottom. Now, as we've seen in the other figures, this whole side is 12, but I only need this portion of it, okay? So when I look at my dotted line, from here to here is 5. This whole thing is 12. That means this has to be 7, so it has a height of 7. So this is 13 divided by 2 times 7, 6.5 times 7. I'm just going to pull up a calculator. Here we go. 6.5 times 7, 45.5 meters squared. Okay. So next I need to find the area of the rectangle. Length times width, which I have 5 and 9. Step 3, I add those together. 45 plus 45.5 equals 90.5 meters squared. So regardless of how you broke up this original figure, you should have ended up with an area in total of 90.5 meters squared. Okay. So this is what you're going to be practicing. There are a few options that you have, and you'll see those linked in Canvas. If you have any questions,